Good morning, and welcome to You, Math, and Me. I'm George Randall, and again, good morning. Today, we're going to be talking about variables. And variables are used as a shorthand way to express relationships. And again, mathematical relationships. And it says that variables are symbols that represent a quantity in a mathematical expression. For example, and again, we're going to use the letters A through Z as our variables. But I suggest that we do not use the letter X, because what does it look like? Our times table. So when we're using our variables, don't use that X. Because what does it look like? The letter X, or a times table. Now, I have a couple examples here, and what we're going to do is take the English language. Again, I've talked about reading, being able to read, and it says, a number increased by 5. And the way we write that with our shorthand is in plus 5. That means increase. Next one. 3 less than 5 times a number. Again, that English language. 3 less than 5 times a number. Less than implies subtraction. 5 times implies multiplication. So what came first? Are we subtracting first? No. We are multiplying 5 times a number and subtracting 3. And the last example, a number multiplied by 12 is 84. And in this case, a number M multiplied by 12 refers to equal 84. Now, if we know our basic facts, we know that that particular answer is 7. And again, variables used as a shorthand way to express relationships in mathematics. Okay. Now, last week, we talked about fractions, and we talked about multiplication of fractions, and we talked about division of fractions. And all the time, I always refer to our basic facts when working with our fractions. We have to know our basic facts. And today, we're going to look at addition and subtraction, but we're going to start off with something very simple, adding 1/4 and 1/4. And what we do is we look at the numerators, and we go 1 plus 1 is 2, and we keep that same denominator, 4. And again, I spoke of putting that particular answer in simplest form. Is it in simplest form? No. And we have to list our factors for 2, 1 and 2, and our factors for 4, 1, 2, and 4. And we take our largest factor, which will go into these two numbers evenly, and divide. And 2 divided by 2 equals 1, and 4 divided by 2 equals 2. And then again, those relatives, 1 times 2 is 2, 2 times 2 is 4. And again, that's a simple addition of fractions. Now we're going to look at something a little bit more difficult. We're going to look at 1/14 plus 1/21. Now, looking at that right now, You can't add this denominator and that denominator. A lot of people say 1 plus 1 is 2, and then 4 plus 1 is 5, and 1 plus 2 is 3. No, can't do that. In order to add this particular fractions or these particular fractions, the denominators have to be the same. So we have to write an equivalent fraction for 1/14 and where the denominators are the same. So what do? We multiply or take the factors, and in this case 2 times 7 is 14, and down here 3 times 7 is 21. And then we take all the prime numbers, one of each of these, and 2 times 3 is 6, and 6 times 7 is 42. And that's called the least common multiple. And we're going to use this least common multiple as our denominator. And what that means is this is the smallest number that both 14 and 21 will go into evenly. And again, how do we do that? Okay, I'm sorry. We're going to multiply by 3, and down here, whatever we do to, no, I'm sorry, we are going to divide. 14 goes into 42 3 times, and 21 goes into 42 2 times. Now we can add our numerators, okay? And 2 plus 3 is 5 42nds. And now we've added these two fractions. We first had to get equivalent denominators and then equivalent fractions. 1/14 equals 3 42nds. 1/21 equals 2 42nds. We add the numerators and we get 5 42nds. And that cannot be simplified because 5 is a prime number. It's only divisible by itself and 5. And that's how you add a basic fraction. We can do the same thing with a mixed number. And last week I said to you a mixed number is a whole number and a fraction. 5 1/5 plus 2 1/3. And we can set this up just like we do whole numbers. We can add the whole numbers first. That's 7. But again, we have to find a least common multiple, a number that 3 can go into evenly and 5 can go into evenly. We can always multiply 3 times 5 and get 15. Right? And again, that's the equivalent fraction for 1/3. And that's the equivalent fraction for 1/5. 1/5 equals 3/15. 1/3 equals 5/15. Again, we add the numerators. 3 plus 5 is 8. And we keep the same denominator. Is this in simplest form? Yes, but we must check. List all the factors of 8. We got 1, 2, 4, and 8. Can any of those numbers go into 15 evenly? No. So this fraction portion of this answer is in simplest form. And your final answer would be 7 8/5. Any questions? Okay. So we've added a mixed number, and we've just added some simple fractions. let's look at subtraction. We're going to use the same numbers, 5 and 1/3, oh, I'm sorry, 1/5, and 2 and 1/3. And we said that the 1/3 equaled 5/15, and the 1/5 equaled 3/15. Now this is subtraction, and we're looking at 3/15 subtract 5/15. Can you do that? No. And this is just like subtracting whole numbers, where you have 471 subtract 229. And remember the rule, you borrow 1, and actually you're borrowing 10, so that becomes 11. Subtract 9 is 2. 6 subtract 2 is 4. And 4 subtract 2 is 2. And how do you check? First we subtract it. Now we're going to add. 11, carry the 1, 3, and 4 is 7. And 2 plus 2 is 4. Look at that. Back where we started. What do we have to know? Our basic facts again. We were able to subtract. We were able to add. Now over here, this numerator is larger than this numerator. So we're going to borrow 1. And over here, we'll do this. 1 equals how many 15ths? And if we express it like that, we're multiplying by 15, right? Whatever you do to the denominator, you do to the numerator. So we're going to re-express the 1 that we borrowed as 15 over 15. And we're going to add this numerator and that numerator. We're going to get an improper fraction for that little bit. And now we can subtract the fractions. 18 subtract 5 is 13 over 15. And over here, 4 subtract 2 is 2. And real quick, again, that's our final answer, 2 and 13/15. And real quick, we can check it. We just did what we call subtraction. And I keep talking about those relatives called addition. Here we go. 5 plus 13/15, or 5/15 plus 13/15 is 18/15, which is 1 and 3/15, right? Because 18 divided by 15 is 1. Our remainder is 3. Our remainder becomes the numerator. Our divisor becomes the denominator. Now, is that in simplest form? No. We're going to divide by 3, numerator and denominator. 3 divided by 3 is 1. 15 divided by 3 is 5. So we have 1/5 that we're going to add. 2 plus 2 is 4, plus 1 and 1/5, and that equals 5 and 1/5, and that is where we started. With whole numbers, the practice is the same. We must know our basic facts. Here, we'll erase this. I checked it. Again, our answer was 2 and 13/15. Then we turn around and add back and we get where we started. Okay, so that's subtraction and addition of fractions. Now, again, if you have any questions, you can contact me at gerandall22@gmail.com. So, I'd like to take a moment and talk about our toy drive. Here at Vox Wave, Toys for Tots, we have a 2017 toy drive for the kids. You can bring your toys to 4711 Off Place in Suitland, Maryland. And again, I have a toy to donate, and I hope you will too. And we'll be right back, and I want to thank you. Again, this is George Randall, you, Math, and me. Thank you. again, and welcome back to You, Math, and Me. And now we're going to look at a word problem. Remember, I said last week we must be able to read and understand what it is we're looking for. And real quickly, it says Arthur worked overtime the following minutes. He worked 45 minutes extra, 30 minutes extra, 15 minutes extra, 45 minutes extra, and 30 minutes extra. And the question is, how many overtime hours did he work? it has a little note. 1 minute equals 1/60th of an hour. Now, 1/60th of an hour. So, there are 60 minutes equals 1 hour. Okay? Now, the way that we're going to determine this, and we can do all of it in your head. Again, you said 60 minutes equals an hour. We could take this one and this one. That's 30 and 30. That's 60. That's 1 hour. We could take this and this. That's 15 and 45. That's 60. That's another hour. And we're left with 45 minutes, right? Which expressed is 45 over 60, a fraction, okay? So we already know that he's done 2 hours, and now we've got to convey this 45/60ths in simplest terms. And for both of these, we'd list our factors. And that would be 1 for 45. It would be 1, 3, 5, 9, 15 for that one. And for 60, 1, 2, 3, 4, 5, 10, 15, 20, 30, and 60. So the largest factor for both of these numbers would be 15. And again, we take the numerator, divide by 15. Whatever you do to the numerator, you must do the denominator. And 45 divided by 15 is 3. And 60 divided by 15 is 4. So, the final answer would be, and now we're adding, 2 3/4 hours. Again, that's the overtime pay that Arthur would get. Now, we did not give the value of the overtime pay, but that would be the number of hours. But in this case, 2 3/4 hours. That's how many hours he worked overtime for the 5-day period. And that was a word problem. Again, read, what are they looking for, and you're able to solve the problem with enough information about it. And that was a real-life application. So when you're out there working, you'll know exactly the amount of overtime that you've put in, and because you'll know your hourly wage, you'll know how much money you should receive in reference to overtime. Okay. Now, back to some addition problems, because we want to make sure that you understand that. So and we'll again look at some basic fractions where we have 3/4 plus 1/2 plus 1/6. Okay, so we got 3/4 of a pie, 1/2 of a pie, and 1/6 of a pie. And again, we have to find a common denominator, or the least common multiple. Again, that's the smallest number that 6, 2, and 4 will go into evenly, so that we can write equivalent fractions. And I like to take the 6, and 1 times 6 is 6, 2 times 6 is 12. Right there. Can 6 go into 12 evenly? Yes. Can 2 go into 12 evenly? Yes. 4. Yes. So we're going to use this as our denominator for these fractions. Okay? So, what number multiplied by 6 will give us 12? 2. Whatever we do to the denominator, we must do to the numerator. What number multiplied by 2 will give us 12? 6. Again, whatever we do to the denominator, we must do to the numerator. And the last one, what number multiplied by 4 will give us 12? 3. And again, so now 3/4 equals 9/12. 1/2 equals 6/12. 1/6 equals 2/12. We add the numerators. 2 plus 6 is 8. 8 plus 9 is 17 over 12. That's an improper fraction. Okay? So it's not in simplest form. And now we have a division problem. 17 in the house divided by 12. We can only get 1 12 out of 17. Our remainder is 5, which becomes our numerator. And our divisor 12 is our denominator. And adding up 3/4, 1/2, 1/6 is 1 pi and 5/12 pieces. Okay? Least common multiple was 12, which again is the smallest number that 4, 2, and 6 will go into evenly. And another subtraction. Again, we have 7 1/8 subtract 3 1/6. Multiples of 8. 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. Can 6 go into 24? Yes. That's our least common multiple. Okay? And again, what number multiplied by 6 will give us 24? 4. And again, whatever you do to the denominator, you must do to the numerator. 1 times 4 is 4. Up here, we already know 8 times 3 is 24. 3 times 1, 3. We've written equivalent fractions for 1/8, 1/6. We also found out which was larger. 1/6 was larger than 1/8. So now we got to borrow again. And borrowing, just like we do with whole numbers, 6 1/12, subtract 3 0 7. We borrow, that becomes a 0. That's 12 minus 7 is 2. 0 minus 0 is 0. And 6 minus 3 is 3. Then we add 7 plus 5, 12. 6 plus 6, and we're back to where we started. Okay, so we're going to borrow here, and we're going to express 20. This 1 equals 24 over 24, and we have to add that here. And this is 27 over 24. Now we can subtract. 27 minus 4 is 23 over 24. 6 minus 3 is 3. This is our answer, 3 and 23 24ths. And we can check it. just by doing this. 4 plus this, 27 over 24. And here, 3 plus 3 is 6. Convert this back. And I wrote 26, it should be 24. 27 in the house. That's 1 time. 3 is the remainder, that's 3/24. And we said that 1/8 is 3/24. And we add 1/8 to 6. 1 and 1/8 to 6. And we get 7 and 1/8. And that's where we started. All basic math skills. Now, again, if you have any questions, you can reach me at GERandall, RANDALL 22@gmail.com. And I want to thank you again for coming in and seeing me today. And again, if you need me, you can reach me at my email address. Thank you, and we'll see you next time. Hey, I made it. Boy, that went fast.